In this video, we'll generate the dataset of PHI and ERF function using Taylor-Maclaurin series sum and array formula. We'll derive the PHI function as well and the ERF function. We begin with the PHI function using array formula. Phi of the x values from -2 to +2. And here's the trend line and the trend line equation. Next, we generate the ERF function. Array formula, ERF of x from -2 to +2. And here you have the ERF function. We'll derive this using the Taylor-Maclaurin series sum from the Gaussian integral and the Gaussian function. We begin with the phi function, which is equal to 1 over square root of 2 pi times the summation of a times x to the power 2n, where our value of n is from 0 to infinity. In this case, we can go as far as 8, maybe. And we use the series sum. So array formula, series sum of the x values raised to the power n, which starts from 0, incremented by 2. And the coefficient will be this range in blue. Now we can continue with the coefficients, which is array formula. -1 to the power n all over. There are two parts, factorial of n times 2 to the power n. So this is our value here, which corresponds to this. What's missing is the 1 over square root of 2 pi. So we factor in 1 over square root of 2 pi here. That is, so inside the parenthesis will be 1 over square root of 2 times pi, enter. Now they're all in the same trend line. That's the same trend line, and the regression coefficients are the same. And the data sets are also the same. Now we continue with the ERF function. We derive the ERF function, which is equal to 2 over square root of pi times the summation of a times x to the power 2n plus 1, where a is equal to -1 to the power n over n factorial times 2n plus 1. And first we use the series sum. So array formula, series sum of the x values raised to the power 2n plus 1. So starting from 1, incremented by 2. And the coefficient will be this range. Now we calculate the coefficient. So it is equal to array formula -1 to the power n all over. There are two parts, the factorial of n, that's the factorial of n, times the quantity 2 times n plus 1. Here. Now they are not on the same trend line, but we're missing the 2 over square root of pi. So we have to factor in 2 over square root of pi. So this will be times. Inside the parenthesis will be 2 over square root of pi. 2 divided by square root of pi. Enter. Now they're on the same trend line. And their trend line equations are the same. So the regression coefficients are the same. And their data set, well, they are the same to this portion. But the error is very small. So the approximation is good enough to approximate the ERF function. This completes the use of Gaussian integral and the Gaussian function to derive the Google Sheet functions of phi and ERF using Taylor-Maclaurin series sum and array formula.